Hey guys, so in this video I want to talk about measuring quantum states. So earlier in the series, like the second or third episode, we talked about measuring classical states and how, let's say, if you had a weighted die or something like that, you could have a certain probability of landing on one of the six faces. But every time you roll that die, it lands on a certain state in that system, whether it's 1, 2, 3, 4, 5, or 6. Now, in the idea of quantum systems, the whole idea is probabilities in these types of states. But instead of like a system with six states, let's just deal with a qubit or a quantum system with only two states, the zero state and the one state, or the ket zero, ket one state. So we talked in previous lessons about how mathematically that ket psi function can be represented by some alpha ket 0 plus beta ket 1, and how those alpha and beta values can be transformed into the probabilities of achieving either the ket 0 or the ket 1 state in a qubit. But when you measure this quantum system, when you actually, go in and you measure it. Now, physically, I'll talk about what this is later. When you go in and measure this quantum system, it collapses. It's what's called a wave function collapse into either the ket 0 or the ket 1 state. Or in a classical system, it collapses into the 0 state or the 1 state. And it collapses in accordance with the probabilities we discussed in the previous lesson. The absolute value of that alpha value squared is the probability of getting ket 0, and the absolute value of the beta value squared is the probability of getting ket 1. Now, when you measure that quantum system, it collapses into either the 0 state or the 1 state in accordance with those probabilities. And if you go back and measure twice, measure like immediately after the first measurement, you will see that that quantum system is now just ket 0 or ket 1. And those quantum systems have, they're certain that it'll be either ket 0 or ket 1. Unless there's a certain amount of time between the measurements, you're either going to get what you measured in the first measurement. Now, the physical meaning of measuring quantum systems comes down to what I mentioned a couple of videos ago with the double slit experiment. I encourage you to go and check out like a video on that separately because that's a very good like physical interpretation of what a quantum state is. It's like if you have two slits and you don't measure it, those waves that go through the two slits will interfere, or if it's just a single photon passing through the double slits, it will interfere and act like a wave. And in that state, you see the probability is coming to light. But when you put a photon detector on the other side of those slits, the wave function collapses in that state, or it collapses into either a ket 0 or ket 1 in this analogy. And you go from having a quantum system to a classical system where you know it's either in one state or the other. So yeah, that's basically how quantum measurements work. Thank you guys. Bye.